Thanks everyone for being here. We're very happy to share this meetup with you and with the amazing guys at ClickHouse. Today, I'll be sharing an experience report on regarding our migration from Elasticsearch to ClickHouse that we started 4 years ago and how it's been so far. This reports on the work done by my very talented teammates on the data team and the platform team at Contentsquare over the last 4 years. I'm Ryad Zenine. I'm a senior data engineer at Contentsquare, and today I'm the storyteller. So at Contentsquare, we build tools that allow you to analyze and improve user experience on digital platform. We are mainly focused on enterprise customers, as you can see by the logos on the slide. We were founded in 2012, and today we are over 1,000 employees. On a typical day at the office, we would record 1 billion page views. Our busiest cluster would serve 100,000 analytics queries, and the average response time of those queries executed in ClickHouse is going to be 200 milliseconds. We are running approximately 100 machines today using ClickHouse. We have several clusters. Most of them have 9 shards. We have 2 replicas per shard. We are running ClickHouse on 2 different cloud providers, and we have 4 open regions, which means that we have 8 clusters running in production today and serving clients worldwide. What Contentsquare will provide you, and I'm telling you this to give you more context about our technical challenges and why ClickHouse was a good fit for our use case. Contentsquare is going to give you the ability to analyze the behavior of your users that are browsing your website or using your mobile application through different lenses and different perspectives. So you could be interested, for example, in how they're interacting with your products, how their journey is going, what are the errors that they're encountering on their journey, how they're consuming content, how they're interacting with that new design that you just released. And for each one of these perspectives and for each one of these lenses, we're going to allow you to drill down into very specific populations. For example, you could be interested in analyzing people that came from online advertising, so paid advertising, visited 3 product pages, added a running shoe to cart, went to checkout, had an error, and started refreshing the checkout page in a loop. A Contentsquare user could come up with a pattern like this on the fly, and within seconds, we will be able to give him all the relevant KPIs and impacts and for that population over the last 13 months of data, which imposes on us, and that's why I took the time to explain a bit the context. This imposes on us a couple of constraints. The first one is that we can't pre-compute anything because all of those populations, all of those segments and those perspectives can be defined on the fly by our customers. So as a user, you don't have to think in advance on the analysis that you're gonna run. You can observe something in practice and go to Contentsquare, set it up, and you have your results in seconds. We can't pre-compute anything. Everything has to be retroactive, and we serve that over 13 months of data, which puts the scene. So 4 years ago, we were doing this on a couple of Elasticsearch clusters. So we had 14 of them. Each one of them was running 30 nodes, and we were struggling to make them bigger while keeping them stable. So we had a lot of them. And this imposed several limitations on our company and its growth. The first one is that given that we couldn't make those Elasticsearch bigger while keeping them stable, we were unable to host very large clients with very high traffic in a stable and comfortable way. So if you were to sign a deal with somebody that has too much traffic to fit on your cluster, then you're going to have a hard time delivering quality experience to that user. The second struggle was that as the traffic of our clients grew, some of them would outgrow the capacity that was remaining on the cluster that they're living in, and their experience using the application would degrade. And therefore, we spent a lot of times and ops moving clients from one cluster to another to make sure that everyone is having a good experience. This kept the team busy for several days, sometimes at nights we had some on-calls, some stability issues. And this is when we decided to look for another database. At the time, the team looked into a couple of different technologies with several requirements in mind. We didn't want to have any vendor lock-in. We wanted very low latency. We wanted the technology to work really well with disks. Given the size of our data set, it was not reasonable to go for a full in-memory technology. And we wanted something that was stable and scalable. And this is what led us to, after several benchmarks, to give a try to ClickHouse. We started our migration by building a new commercial product to give a try, warm up, try to learn a bit. It took us a couple of months, and this commercial product and this technical endeavor was a success, which convinced the rest of the company that ClickHouse was actually the correct bet. And after that, we started porting all of our endpoints and all of our APIs from Elasticsearch to ClickHouse. It took 11 months. And then we started migrating the clients one by one, and it took us 4 months. On the first phase of our migration, we decided to build a new product to avoid dealing with the burden of the migration at first, learn how to properly use ClickHouse. It allowed us to build automation and to test it in production setup. So Terraform, Ansible, to correctly build all of our monitoring and alerting stacks for ClickHouse and to get some production experience, although at a smaller scale. Given that we were not exposed to very high traffic on this new product, we also spent some time generating synthetic data sets to try to understand a bit better the behavior of the technology, but it did not replace a large-scale experience and experiment that we did afterwards. On the second phase, what we did was a very classic and iterative process of selecting a bunch of endpoints that belong together, reporting them to ClickHouse, mirroring all the right traffic onto a ClickHouse cluster, replay the queries that were targeting those endpoints, compare results, and fix regressions. We did that in a loop for a couple of months, which allowed us to port all the endpoints one by one. During that time, the team took a couple of decisions that helped us a lot in the migration. The first one was to avoid breaking any API contract. So you might be tempted if you're redoing something to do it better, to improve the API signatures, to fix some quirks and some technical debt that you've accumulated along the way. But we refrained ourselves from doing that, which allowed us to build automation to compare the new system and the old one and spot regressions very fast. So we also invested in automation for data ingestion, replay, and comparison. And we kept the team split into two parts. So we still dedicated some capacity to improve the legacy cluster and the ClickHouse, the Elasticsearch deployment, and build new features on top of it. Well, you pay a price for this for sure, because you have duplicate work. Now you have a team that is porting all of your current API and infrastructure onto a ClickHouse database, and the other one that is improving and building new feature on the legacy one, which was Elasticsearch. But it also allowed us to avoid a stop the world effect, where for several long months, the company would stop to innovate and would stop to ship new features to the customer. So finding that balance between keeping up with the product innovation and keeping up with the feature delivery while doing the migration was key to the success of the project. Once we were done porting all of the endpoints, we migrated the customers with a lot of care, and we did it one by one. So it took a long period. It took between 4 and 6 months to do this, but we went one customer by customer, and the early investments that we did on the automation of non-regression tested allowed us to actually perform all of that migration with 0 regression. And the team was very happy about that. Migrating to ClickHouse got us a couple of benefits. The infrastructure became 11 times cheaper. It allowed us to increase the retention from our Elasticsearch clusters, where we would keep the data for 3 months. We were able to keep the data for 13 months on a select number of customers by migrating to ClickHouse, and the P99 on the queries was 10 times faster. The average was 4 times faster. It also unlocked a couple of innovation on the product. We were able now to serve all the KPIs and run all the queries on 3 months of history instead of 1. We were able to increase and improve our population analysis by adding the ability to, as I described earlier when I was explaining the context of Contentsquare, to segment and to analyze sequential behaviors. We were able to build form analysis modules and many more. Let's check, are there any questions already in the chat? No, I think we're good. Okay. While doing the migration, we had to adapt ClickHouse a bit to our use cases. And in this part of the meetup, in this part of the talk, I'm going to be sharing the experiments and adaptation that stood the test of time and that are still in production today. So things that we're still very happy with and we keep investing on and betting on. So the first one, when migrating to ClickHouse, we wanted to have as little overhead as possible with our insertions, and we wanted to keep as many CPU time, as much CPU time as possible dedicated to our queries. We did that by building a dedicated Scala component that would embed a ClickHouse local and a ClickHouse client inside of it. And what that component would do is read from a static assignment of Kafka partitions, build the batches locally, optimize them, turn them into native format, and then send them to a designated ClickHouse shard. This saves some CPU on the production cluster. And it allows us to have very little overhead on our inserts. It also means that now the insertion component and the shard are tightly coupled, and every time we have to do an operation to change our schema on ClickHouse, we also have to do an extra release on the insertion component because the component has to be aware of the schema in order to use native format. This brings some coupling and a bit more overhead on the operations, but we kept that design for a couple of years and we're very happy with it. The second one was that we had to build a query optimizer in Scala to simplify the queries that we sent to ClickHouse. So as I was explaining before, the queries that Contentsquare builds are dynamic. So a user can come up with any kind of segment, any kind of subpopulation that he wants to analyze. And we provide interfaces to build very rich populations, to define very rich population on which you can run an analysis, which means that all the queries are dynamic. Most of them are unique. And most of them turn out to be very large. So we took the decision early on to build an abstract syntax tree in Scala to represent our ClickHouse queries and not generate the strings directly, which allowed us to build a query optimizer on top of this AST, which does a couple of nice things. The first one will be to merge all of the subqueries that are targeting the same local table when it's possible, to simplify some algebraic expressions before sending the query to ClickHouse. And most importantly, and this is key for performance, to propagate the partition keys to all of the subqueries when it's possible and relevant. For 95% of our queries, this does nothing. For the 5% slowest queries that we run, this improves the performance 10x. So we're very, very happy with this optimizer, and we keep investing on it. This was typically a technical choice that stood the test of time and that we're happy with. While in adopting ClickHouse, though, 4 years ago, there was some critical features and tools that were missing and that you would expect from other comparable database ecosystems that were a bit more mature. For example, we had to build the backup tools ourselves to do the integration with Vault for user management. We struggled a lot for a long time with schema management, especially before the 2021 versions. because sometimes the shards would get out of sync with Zookeeper, and when you would do an alter table on cluster, the shard would not register it immediately. So you'd have to connect to each one of them to double check. Given the number of nodes that we have, this is very time consuming. So we ended up building tooling to do automatic schema management. Deletes and updates on ClickHouse are a bit hard and very heavy on the cluster. So we had to build tooling to be compliant with CCPA and GDPR and do manage deletes on our clusters when the load on it is low. We also invested, as I was saying a bit before, on this Scala client that allows you to represent your queries as an AST and to run the optimizer on top of it. And we did some improvement on CH proxy that you'll hear about from my colleague in a couple of minutes. We are still investing some energy and resources into improving our upgrade story with ClickHouse and all the data rebalances when you add new shards. But these are the topics that we're working on. Thank you, everyone. I think that was it. We are sharing a lot of what I was talking about today. For example, all things related to sequential segmentation on our engineering blog. So I'll invite you all to take a look. There will be some very nice and interesting topics about ClickHouse there if you're interested. Thanks, everyone, for giving me the time.
Thanks, Ryad. We did have one question in the chat if you want to take a look.
Let's cover it.
Or two questions now.
I can take. Okay, Guillaume. We are running at a scale where the conversion to native is actually costing us. So we benchmark, for example, and maybe Francois can tell you a bit more about this later. We benchmark using protocol buffer or other more generic formats to do the insertion, and we lose 20%. This is something that we don't want to keep on the table, and we want those 20%, and we are ready to invest and to deal with the complexity. The complexity that comes with it, but this is very specific to our use case, I think, and on most use cases, this might be overkill. Alexei, we could actually share the exhaustive list, I think, of what would be needed, but the most important one and the big difference maker is propagating the partition key everywhere. Sometimes you can also, by analyzing the query, set the distributed group by no merge to the correct value, but you need knowledge of the data set, which we have at the API level, but maybe ClickHouse in the C++ code base doesn't. Merging subqueries that are hitting the same local table is also big for us. So it makes a big difference, but it's also linked to the very dynamic nature of our queries and the fact that we have very little control on what's going to get generated. And most of the time they're very big and very complex. There are several of them, for example, that don't even fit in the query log of ClickHouse because of size.
Okay, just in case, I will repeat. I will tell what was the question. The question was, why do you need this custom AST optimizer on your site? And what shall we do on ClickHouse? What ClickHouse shall do? What optimizations it has to do by itself to make your custom optimizer unneeded? Yeah, and I understood that it contains large amount of domain-specific knowledge, but some of the optimizations, like pushing condition key as much as possible, probably we can improve, and it will help. It will also help. It will also help if you can share some example of your queries. I like these queries that don't fit on the command line.
Yeah, I think we'll be able to do that. We'll come back to you.
Okay.